Hello everyone, welcome back to Vidmahi Maths Academy. In the previous video, we learned inverse of sine, inverse of cosine and inverse of tangent functions. In today's video, we will understand the remaining three inverse trigonometric functions such as inverse of cotangent, inverse of cosecant and inverse of secant. Let's begin. Now, we will understand first inverse of cotangent. For that, consider a function cot function. Observe the graph. See here, cot 90 is 0, cot minus 90 is 0, cot 270 is also 0. So that cot function is not 1, 1. Since cot 90 is equal to cot 3 pi by 2 is equal to cot minus 90 is equal to 0. That means multiple elements having the same image, same value. So therefore, cot function is not 1, 1. So that we have to restrict the domain. Observe here, from 0 to pi, in between that, here dotted line represent except that point. That means at 0, at 180, at 360 values, cot function is not defined. So that's why here dotted line represent the except that point. So that observe here, in between 0 to pi, cot function is decreasing and also cot function is 1, 1. So that 0 open interval 0 comma pi. In this interval, cot function is 1, 1. Again, pi to 2 pi. In between pi to 2 pi, the function cot function is 1, 1. So open interval pi comma 2 pi. So on. And also minus pi to 0, open interval minus pi comma 0. In this interval also cot function is 1, 1. So on up to etc. In all these interval, cot function is 1, 1, but we consider a one interval that is called as a principal value branch. So here 0 comma pi is called as principal value. Now cot function, cot x, domain is 0 comma pi, open interval 0 comma pi, and the range is set of real numbers. So in this case, cot function is bijective. Cot function is bijective. So that inverse of cotangent function. That means that can be represented as cot inverse x. Inverse of cotangent function, here domain of the cot function becomes range and range becomes domain. So that cot inverse x from set of real numbers set to open interval 0 comma pi. Here domain of inverse of cotangent function is set of real numbers and the range of inverse of cot function is open interval 0 comma pi. Now if you observe the graph of cot inverse function, observe here. So on the x-axis, so 0, 1, -1, and here you represent pi by 2 pi. Okay, except 0, correct, except 0 values, it's dotted line, except 180 value, dotted line. In between that, so cot inverse 0, where the cot function value is 0, at pi by 2, correct. So therefore cot inverse 0 is pi by 2, and cot inverse 0 is pi by 2. Okay, now where the cot function value is 1, at pi by 4. Yes, so therefore cot inverse 1 value is pi by 4. Pi by 4 is here. So pi by 4, cot inverse value is pi by 4. Now, where the cot inverse value is -1, 135 degree, 135 degree is in between pi by 2 to pi, correct. 135 degree is here. So at here it is, the value is -1. Now if you join all these points, so you will get the graph like this. Okay, so this is the graph of cot inverse function. Now next one is secant inverse graph, secant inverse function. For that we have to consider a secant function. Observe the graph, observe here, secant 0 is also 1, secant 360 value is also 1. So that secant function is not 1, 1. Secant function is not 1, 1. Since secant 0 is equal to secant 2 pi value is equal to 1. Secant 0 is equal to secant 2 pi is equal to 1. Multiple values, multiple elements having the same value. So therefore this is not 1, 1. So we have to restrict the domain. So observe here, minus pi by 2 to pi by 2, in between that, because at exactly pi by 2 to minus pi by 2 to minus pi by 2 and pi by 2, secant value is not defined. So accept that values. In between that, observe here, from 0 to pi by 2, 0 to pi by 2, this one, and pi by 2 to pi here. Observe these two, from here to here this is a 1, 1, and from here to here this is 1, 1. So we have to consider here the interval 0 to pi except pi by 2. So consider closed interval 0 comma pi except pi by 2 value, because at pi by 2 secant value is not defined. So in this interval function is 1, 1. Again observe pi to 2 pi. So observe here pi, so here the graph from this side and here. So this is 1, 1. So closed interval pi comma 2 pi except 3 pi by 2, except 3 pi by 2. Similarly, if you observe minus pi to 0, minus pi to 0, observe here from here to here and here. Function is, in these two function is 1 1. That means minus pi comma 0 except minus pi by 2, except minus pi by 2. Here minus represent except that point, minus represent except that point. So on in all these etc in all these intervals, secant function is 1 1. But we consider a one interval that is considered as principal value branch. Closed interval 0 comma pi except pi by 2 is the principal value branch. Now secant x function becomes secant x domain is 0 comma pi, closed interval 0 comma pi except pi by 2, and range of the function is r minus 1 comma 1. So this is here secant function is bijective, but bijective means both 1 1 and on 2. So now inverse of secant function. Inverse of secant function here represented as secant inverse x. Domain of secant inverse x is r minus open interval minus 1 comma 1 to closed interval 0 comma pi except pi by 2. So here domain is r minus 1 comma 1, that should be in open interval, and the range is closed interval 0 comma pi minus pi by 2. Now if you observe the inverse function graph, secant inverse graph, observe here. So this is 0 1 minus 1, this is 90, and this is 180, y axis, this is x axis. So except pi by 2, except pi by 2, consider here dotted line, except pi by 2. Now tell me, what is secant inverse 1? That means where the secant function value is 1, at 0. Yes or no? Yes. Secant inverse 1 value is 0. So next, where secant function value is minus 1, at 180. Yes. So secant inverse of minus 1 is 180. So secant inverse of 1 is 0. 0 is, so secant inverse of 1 is 0, and secant inverse of minus 1, secant inverse of minus 1 value is 180. And if you consider one more value, secant inverse of 2, where the secant function value is 2, at 60 degree. Yes, pi by 3. So secant inverse of 2 is equal to pi by 3. So secant inverse of 2. So here it is 2. Secant inverse of 2 is pi by 3, 60 degree. So now if you join the dotted lines, so you get the graph like this. Okay, so this is the graph of secant inverse function. Next function is inverse of cosecant function. To understand that function, first we have to consider cosec function. Observe the graph. Cosec 90 is 1 and cosec minus 270 is also 1. So that cosecant function is not 1 1. Is not 1 1. Cosec 90 as well as cosec minus 3 pi by 2, so on. In all these values, value is 0. So multiple elements having the same value, so therefore cosec function is not 1 1. So we have to restrict the domain. Observe here, from minus 90 to 90, in between that 0 is not included except that value 0. So that observe here minus 90, so the function is like this and here it is like this. So minus 90 to 90 function is 1 1. So we can consider closed interval minus pi by 2 comma pi by 2 except 0, because at 0 cosec function is not defined. And observe 90 to 270, pi by 2 to 3 pi by 2 except this pi. So here the function is like this, from here to here and here to here. So function is 1 1. Pi by 2 comma 3 pi by 2 except pi, so on. And also observe here minus 3 pi by 2 comma minus pi by 2. Observe here the graph is like this. So the function is 1 1. Minus 3 pi by 2 comma minus pi by 2 except minus pi, so on, etc. In all these intervals, cosecant function is 1 1. Consider the principal value branch. Minus pi by 2 comma pi by 2 except 0. This is called as principal value branch. So now cosecant x function, cosec x function becomes domain is minus pi by 2 comma pi by 2 closed interval except 0, and the range is r minus 1 comma 1. So now inverse of cosecant function, that can be represented as cosec inverse x. Cosec inverse x, here domain of the cosec function becomes range and range becomes domain. So that r minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2 except 0. So here domain of this function is r minus 1 comma 1, and range of this function inverse cosec function is minus pi by 2 comma pi by 2 except 0. Now if you observe the graph of this function, so this is 0, this is minus 1, 1 x axis, y axis. So here it is pi by 2 pi, this is minus pi by 2. Now first tell me cosec inverse 1. That means where the cosec function value is 1 at 90. So cosec inverse of 1 is 90. Cosec inverse of 1 is 90. Before that, first we have to consider the dotted line at 180 because that is except that point, and 0 is also except that 0. Now, okay, cosec inverse of 1 is pi by 2 and cosec inverse of 2. Where the cosec function is 2 at 30 degree, that is pi by 6. Pi by 6. So here it is 2, 30 degree, pi by 2. So okay. Now if you join this, you will get okay like this. And where the cosec function value is minus 1 at minus 90, minus 90, minus 90. And where the cosec inverse function value is minus 2, that is minus pi by 6. Minus pi by 6 means minus 30. Here it is minus 2, minus 30. So if you join this, you will get the graph like this. So this is the graph of the cosec inverse function. Now if you observe the table, this is very important for MCQ. Domain and range concept, domain and range concept of inverse trigonometric function is very important for your MCQ question. Okay, so sin inverse x, cos inverse x, domain range, tan inverse x, secant inverse x, cosec inverse x, and cot inverse x. And one more important thing here, r minus minus 1 comma 1, r minus minus 1 comma 1 can also be written as minus infinity comma minus 1 union 1 to infinity, 1 to infinity, and r minus minus 1 comma 1, that should be open interval r minus, so that can also be written as minus infinity comma minus 1 closed interval union closed interval 1 comma infinity. So this is the domain of secant inverse x and cosec inverse x function. If you found this video helpful, please like, share and subscribe to Vidmahi Maths Academy. Thank you for watching and I'll see you in the next video.